All right, so we are working on some substitution, and we're looking at the integral of cosine of 5x plus 8 dx, and we notice an inner function as the 5x plus 8, and so that's a good candidate for u. So I already did this one. I'm going to redo it up here. I did it in a video that didn't end up saving correctly. Okay, so my u is going to be the inner function, 5x plus 8, and then that gives us a du of, okay, so the derivative of 5x is 5 times the differential dx. Now, I have a dx, but I don't have a 5 dx, and so I'm going to divide this 5 off so that I can figure out what to replace dx with. So I'm going to take 1/5 du equals dx, and now I know that I'm able to replace dx with 1/5 of du, and we can replace the 5x plus 8 with u. So we're going to make those two changes as we substitute. So the integral becomes the integral of cosine of, okay, this got replaced with u, so it's cosine of u. And then the dx is getting replaced with a 1/5 du. Now, sometimes I would go ahead and just write the 1/5 out front if I'm feeling ready to do that. So we have 1/5 integral cosine u du. Sometimes what I was trying to get at is I might not write this second line. I might just go ahead and immediately put the 1/5 out front because I know it's going to come out eventually. Now I'm going to integrate the cosine of u. I know the cosine of u integrates into a positive sign. So I have 1/5 sine of u plus c, and then if we replace that u back to what it started with, we're going to have 1/5 sine, I'll just move, 1/5 sine of 5x plus 8 plus c. So like I had here with a little more color on my new one. Okay, so I just didn't have room to write it, so c below. 1/5 sine of the original u, 5x plus 8 plus c. So there we go. All right, so taking a look at the next one. Okay, in this one, again, if I'm going to use u substitution, it's got to be for composition. And so composition needs to have an inner function. So we're seeing that there's an inner function because it's inside this square, so that's a prime candidate for u. So let's try u equals x to the 4th plus 3, and then we'll find its differential. So du, okay, so the derivative of x to the 4th is 4x to the 3rd times the differential dx. Now here, I don't have a 4x to the 3rd dx, but I do have an x to the 3rd and a dx. They are multiplied together even though they're not right next to each other, and we're going to use that fact. I just need to divide the 4 off. So if we divide both sides by 4 and write 1/4 du equals x cubed dx, then I'm going to be able to replace both x cubed and dx together with the 1/4 du, and we're going to be able to replace the x to the 4th plus 3 with u. Now, it's actually very important that I had an x cubed here. If I had an integration that did not have the x cubed times the x to the 4th plus 3 squared, this substitution would not work. I need an x to the 3rd times a dx to be able to sub in my du. I have to have only x's on this side. I don't want to mix my x's and my u's if I can help it. So I need to have the x to the 3rd and the dx together to substitute, to pair and substitute for 1/4 du. So that's an important thing to note here. So now I'm going to replace the purple things become the 1/4 du, the orange becomes u, so it's going to be u to the 2nd times, and then our 1/4 du. 1/4 is just a constant multiple, so we can write that out front. And then we have 1/4 integral of u squared du, which is 1/4 U squared is going to integrate to U cubed over 3 plus C. And so that's 1/12 U cubed plus C. And then we're going to replace that U again with the x to the 4th plus 3 and get 1/12 x to the 4th plus 3 cubed plus C. Okay, I remember what happened in the video. I got this far and then I noticed that this window wasn't showing. I think that was the problem, is it was recording fine but not showing. So now we're still able to see, and we're going to move on to part D. Okay, so mouse in the way. Okay. I need to find an inner function. What seems to be the inner function on this one? I would probably actually rewrite this first because it's in shorthand notation with that cosine to the 9th. I know that that means cosine of x to the 9th times sine of x dx, but just making it a little more obvious right there to see that I do have an inner function, and the inner function is the cosine of x. So that's my candidate for u. I'm going to try first. So u equals cosine of x, and that means that du, so the derivative of cosine is negative sine of x dx, the differential. Make sure you pay attention to those trigs because we are doing both derivatives and antiderivatives in the same problem. It's going to be tough to watch our signs and be careful on that. The antiderivative of cosine is positive sine. The derivative of cosine is negative sine. Keep them straight where possible. Don't mix them up. Now, I have a sine x and a dx, luckily, because I need to get rid of this sine x with this dx. What I don't have is a negative, no big deal, divide it off. Negative du equals positive sine x dx. If there wasn't a sine x up here in the original, I would have been in big trouble. Luckily there was. There's actually a Calc 2 technique for what to do if there isn't one. But I can replace the pair of sine x dx with negative du. And I also replace the cosine of x with u, and we go into our substitution step. So we have the integral. It is u to the 9th times negative du. So I'm going to put my negative out front and my du out here. And we're ready to integrate. That negative is a constant multiple. So I have negative u to the 10th over 10 plus c. Replace our u with cosine. So negative 1/10. And I'm going to use shorthand notation for this. So instead of cosine parentheses, we're just going to use the shorthand notation of cosine the 10th of x plus c. We've got our general antiderivative. Okay, on the next page, let's revisit our integration rules now that we're armed with some u substitution knowledge. So these deal with the rules that we gathered in 4.9, the basic anti-differentiation rules or integration rules. They're just rewritten in terms of u. So I'm using du here, and when I integrate these, it's just summarizing him because we may have some sort of du, which is the product of the derivative of u and the differential dx in these. But these should be familiar. They look very similar to what we saw in 4.9. We have the integral of a constant, we have the power rule, constant multiple rule, sum difference rule. The 1 over u integrates to natural log, e to the x integrates to e to the x, or e to the u to e to the u, and so on. We have a few that we didn't see in 4.9. This is the exponential if the base is not e. So it integrates to the exponential. We have to divide by the natural log of the base. We saw that in derivatives, something similar. So that's one that you might want to just note we didn't see earlier. And then it's not very common though. And then we saw the sine, cosine. Here's another one that we did not see earlier. I mentioned that we would get to integrating tangent later. So here's later. We can integrate tangent into negative the natural log of cosine of u. This one I want to make a particular note of, and I'll talk about this one because it is interesting. So that one's cool. We're going to see that in a second. And then cotangent, we got a bunch of other functions here as well. And then we have our secant squared, cosecant squared, and then our arc trigs as well. That tangent one I want to spend a little bit more time talking about right here at the bottom of this page. So if I wanted to integrate tangent, where the heck did that natural log come from, since natural log is not a trigonometric function? So the first thing, we're just going to figure it out. We're going to do the integral of tangent of x. And so because it just requires a u substitution and an identity, tangent of x is the same thing as sine of x divided by cosine of x. And so if I choose a u substitution where u is equal to, I need an inner function, so I want my denominator, that's inside the bottom. If I choose a u equals cosine, then its derivative, du, is negative, I forgot to write du in front of it, du is negative sine of x dx. And so I have a product of sine of x dx that I can replace with, I have to divide the negative off, but with negative du. So negative du is going to equal sine of x dx. So we'll replace that with our negative du, and then in our denominator we're going to replace the cosine of x with u. So this turns into integral of, put the negative from the negative du out front, 1 over u, that's our cosine, du. So that integrates into negative natural log of u plus c. And so when I sub that back in, that is why I have negative natural log of the cosine of x plus c. So I just did mine in terms of x because I started in x right here. They started in u and would have been w subbed or whatever letter, just keeping the variables straight. But that's where this comes from. So that's why I have a negative and a natural log with the absolute value of the cosine in there. It's because we're combining substitution with a rule 5 for integrating 1 over u or 1 over x into the natural log. So some of these, like number 10 and anything with that natural log in it, probably number 12, you can do by hand and prove those identities with the techniques that we currently have, such as u sub. So, fun fact.